So a geometric series is the sum of all the terms in a geometric sequence. So for example, if I have the terms 2, 4, 8, and 16, this will be my geometric sequence. And this formula is how you find the sum of all of those numbers. And this only works if the sequence is finite, which means it ends at a certain point, which this one does. It ends at 16, but if it kept on going forever, then you can't use this formula. So, U1, as we've discussed before in our arithmetic series video, is 2. So, because that's the first term. And R is going to be the ratio between each term. And to find this, you can divide one term by the term before it. So let's just choose this term 8 and divide it by 4. And so 8 divided by 4 is 2. So R is going to be 2. And N is the number of terms inside the sequence. And as you can see, there's 4 terms, 2, 4, 8, and 16. So N is going to be 4 minus 1 over 2 minus 1. And now we just simplify. So 2 times 16 minus 1 over 1, which is equal to 30. And this is the sum of all of the numbers inside this sequence, and we can test this out by just adding them all up manually. So 2 plus 4 plus 8 plus 16 is equal to 6 plus 24, which is 30. So yes, this formula works. So if we have this sequence, how can we find the sum of all of the terms inside the sequence? Well, first, let's just write out the formula to find the sum or the series of any sequence. So Sn is equal to U1 times R to the n minus 1 over R to the n, just R minus 1. And now, since there's 10 terms, n is going to be 10. So sum of 10 terms is equal to U1, which is the first term. It's going to be 12 times R. What is R? And as we said before, we can find R by just dividing any term by the term before it. So let's take 3 and divide by 6, and we get 1/2. 1/2 to the power of n, which is 10, minus 1, all over 1/2 minus 1. And if you put this into your calculator, you get something around 24. And so this is how you find the sum of any geometric sequence. You just use this formula. And another formula that you can use, SS of n, is equal to U1 times 1 minus R to the n, all over 1 minus R. Both of these formulas will output the same answer, but I would recommend just sticking with this one, because to me it's just more reliable, unless you're in specific circumstances where you need to use this one. But I would just remember both for now, but I would just always use this one, and whenever you can. But sometimes, even if you still have a geometric sequence that goes on forever, sometimes you can still find the sum of it. And this is what the formula is right here. But how do you know if the sum is calculatable? Well, first you need to find R, and if absolute value of R is less than 1, then it converges. The series converges, which means you can use this formula, and that means the sum of all the terms will exist. However, if absolute value of R is more than 1, then it diverges, which means you cannot use this formula, and that the sum is going to be infinitely large. So for example, if I have like 3, 1, 1/3, it goes on forever, my R is going to be 1 over 3. And the absolute value of 1 over 3 is just 1 over 3, which is less than 1. So this means I can use this formula to find the sum of all the terms. And what I can do is just plug in 3 for U1, and then 1 minus 1 over 3. And I get 3 over 2 over 3, which is 9 over 2. So 9 over 2 is the sum of every single term in this infinite sequence. it's a sum of infinite terms, not just 3 terms, not 4, but every single like term infinitely. So if you have a geometric sequence like this, where it goes on forever, um, we need to figure out if it converges or diverges so we can see if the sum exists or not. So to do that, first we need to find the ratio, or r, and to do that we can divide any term by the term before it. So let's do negative 9 and 18. So negative 9 over 18 equals negative 1/2. And now we need to find the absolute value of this. And if the absolute value of this is more than 1, then the sum is infinite. But if it's less than 1, then we can use the formula for an infinite geometric series. So absolute value of 1/2 is equal to 1/2, which is obviously less than 1. So this means we can use a formula. And the formula is S equals u1 over 1 minus r, where u1 is the first term and r is the ratio. So u1 is the first term, so it's 18 by looking at the data set. So 18 over 1 minus r. And we already calculated here what r is, which is negative 1/2. So negative 1/2. And we get 18 over 3 over 2. And we get 36 over 3. And this is just equal to 12. So 12 is the sum of every single term in this infinite geometric series or sequence. And we calculated that by using this formula. Now let's start doing some practice problems. This one says to find the sum of this geometric series, which is 6 minus 3 plus 1 and 1/2 to 5 terms. And first we need to know the formula to find the sum of a geometric sequence that stops after some time. And it is Sn is equal to u1 times r to the n minus 1 over r minus 1. And since there are 5 terms, n is going to equal to 5. So S5 is equal to u1, the first term, which is 6, times r, which is the ratio. To find the ratio, we just take any term and divide it by the term before it. Let's just take negative 3 and divide it by 6. So we get negative 1/2 to the power of 5, because that's n, minus 1. And then divide it all by negative 1/2 minus 1. And this is equal to 6 times negative 1 over 32 minus 1, all over negative 3 over 2. And if you plug this into your calculator, you get 33 over 8, which is equal to 4.125. And what we did here is we used this formula to find the sum of a geometric sequence and applied it to a geometric series up to 5 terms. So this sequence ended at some point, which is why we had to use this one, which is for a finite geometric series. Now let's do another practice problem. If you think you can do this one, pause the video and try it. But this one asks to find the sum of 18 plus 12 plus 8, which goes on forever. So this is an infinite geometric series, which means we need to see if it converges or diverges. So first we need to find r, which is the ratio between terms. So we can take 12 and divide it by 18. So 12 over 18, which is just equal to 2 over 3. And we need to take the absolute value of this and see if it's less than 1 or more than 1. If it's less than 1, then the sum is not infinite and it can be calculated. So absolute value of 2 over 3 is just 2 over 3, which is less than 1. So yes, we can use the formula. And the formula is u1 over 1 minus r. So u1 is right here, which is 18, because it's the first term, and 1 minus r. And we already calculated here what r is, which is 12 over 18, which simplifies to 2 over 3. So we just write it like this. And then this becomes 18 over 1 over 3. And now we multiply both sides of the fraction by 3, and we get 54 over 1, which is just 54. And first, what we did here is we saw if this infinite geometric series was able to be calculated or if it just had an infinite sum. And the way we did that is to find the ratio between each term and see if it's less than 1, which it was. And then that allowed us to use this formula to calculate the sum of the entire sequence. So everything that I explained in this video and all the problems that I went through should teach you everything that I need to know about geometric series and how to start solving them. If you think you learned something from this video, then please consider liking or subscribing as it helps us out a lot.